So, hello everyone, good morning or good evening or whatever time it is you're watching. So from now on you are going to watch the lessons on here, and you have to take notes, which I will be checking in class, and that means that instead of doing homework at home, you will do homework in class, and that should make it easier for me to help you out with any problems that you have, and harder for you to copy homework of each other. So let's get started. We're going to do chapter 3.4. You need to take notes, so you need to write down all the examples and all the questions I do, and I will be checking it in class. So chapter 3.4 is the chain rule. So before we start, I want to remind you of something called a compounded function. A compounded function is a function inside a function. What do I mean by that? Let's say we have a function that looks like sine of x squared plus 3. So our main function would be sine, and then we have x squared plus 3 inside that function. So the name of our function is hx, and we're going to have to split it into two separate ones. Yep, so the first one, as we said, is sine of u, and we have to be a bit careful because we can't say it's sine of x, because x is the one that's inside the second function. And then our second function, the one that's inside the first one, is g of x, x squared plus 3. Okay, and we can actually write hx is actually equal to f to g of f of x, f of g of x. Yeah, so we've got g inside f. Yeah, f is sine, g is x squared plus 3. Altogether, the function is sine of x squared plus 3. Now, the chain rule will tell us how to differentiate these functions. Okay, at the moment we haven't learned how to find the derivative of functions like these. Okay, but the chain rule is going to tell us how, and we're going to see it in just a moment. Okay, I actually want to show you the derivative of this before I show you the rule, and hopefully you'll be able to work out the rule just from the way I show you the derivative. So, the derivative of sine of x squared plus 3 is cosine of x squared plus 3 multiplied by 2x. Okay, this should look somewhat familiar. We know that the derivative of sine is cosine, and the derivative of x squared plus 3 is 2x. So you might be able to work out this rule for yourself. It's the derivative of the external one, or the main one, multiplied the derivative of the internal one. Okay, let's write out that rule. Okay, so this is the full form of the chain rule. Okay, the derivative of a compounded function, gx inside of fx, is equal to the derivative of the external one, just the fx, with the gx kept inside the same, multiplied by the derivative of the internal one. Okay, so copy this out. This needs to be in your notebooks. We're going to do lots more examples, and that's pretty much it for chapter 3.4. So copy this out and let's see some examples. Next up, we want to differentiate the square root of x squared plus 1. How do we go about doing that? So we know that the derivative of the square root of u, okay, is 1 over 2 square root of u. Okay, we've seen that before. The only difference is that this time our u is not just a variable, it's another function. Okay, and the derivative of that internal function is, of course, 2x. Okay, this is just the preparation we were doing to do the main thing. So, the derivative of fx will be as follows. 1 over 2 square root of, now instead of just writing x, here I need to write x squared plus 1. Okay, and then this is multiplied by 2x. Okay, we can simplify that a little bit. Okay, there you have it. The square root of, or the derivative of the square root of x squared plus 1. Okay, I differentiated the square root function as if there was just an x inside it, okay, and then I found the derivative of the bit that was inside, the little internal part. Okay, let's see some more examples. Just copy all of this down, please. Okay, this time our function is f of x equals x cubed plus 5x squared plus 6 to the power of 4. Okay, in the past we would have had to factor this all out and square this all and raise this to the power of 4, and that would have taken ages. Okay, so the easy way to do it this time, okay, we're going to use the chain rule. Okay, so first we find the derivative of the external one. Okay, so it's 4 times all the stuff that's inside, no change, to the power of 3, just as if we were doing a regular power. Yeah. So the derivative of x to the power of 4 is 4x to the power of 3. Okay, and we've done exactly the same. We've just kept the other function inside. Now, we're not finished. We need to now multiply it by the internal derivative, and that will be 3x squared plus 10x. Okay, now we're going to pretty much have to leave it at that. There's no point factoring it all out. Okay, so copy this into your notebooks too. Okay, we're going to do one more, and then I'm going to want you to do some examples for us. Okay, let's look at one more example. Okay, so this time fx is x cubed plus 1 to the power of 100. Now, I really don't know how to factor the power of 100. When I was doing this one, I might have been possible to kind of multiply this 4 times, but to do the power of 100, I really don't know how. But we have our chain rule, and that will make it quite easy. So, my derivative is 100 multiplied by x cubed plus 1 to the power of 99. Yep. Multiplied by 3x squared. Simplify that a little bit. That will be 300 x squared x cubed plus 1 to the power of 99. Okay, not too difficult. So copy all this out. Okay, this needs to be in your notebook, these examples, because when we get to class next time, I'm going to ask you straight away to do a whole load of classwork and then hand it in to me at the end of the lesson. Okay? Okay, next I've got this function, y equals 2x plus 1 to the power of 5, multiplied by x cubed minus x plus 1 to the power of 4. Now, if you remember our product rule, okay, so we're going to apply it to here. Here, my f is this one, and my g is this one. So let's work them out separately first. Derivative of 2x plus 1 to the power of 5. the derivative of all of that will be 5 2x plus 1 to the power of 4 multiplied by the internal derivative, which is 2. Okay, next up, derivative of x cubed minus x plus 1 to the power of 4 will be 4 times x cubed minus x plus 1 to the power of 3, just like it was a regular x, but we then need to multiply by the internal derivative. That's 3x squared minus 1. Okay, now let's add them all together. So, back to the main question, y equals, so it's this one times this one. Multiplied by our g. Plus the derivative of the second one multiplied by the first one. Okay, quite long and exhausting, but that is our answer. Okay, you can simplify this a bit by multiplying this 5 by this 2, if you wanted to. Okay, copy this out. We're just applying this chain rule to a function that is a multiple. So copy it, please. Okay, so next I'd like you to do these 3 questions only at home, and I will be checking them in class next lesson. First one, I'd like you to find me the derivative of this. Okay, once you're finished with that, I want you to find the derivative of this one. And last but not least, find the derivative of, what shall I give you? Something difficult. Okay, the last one is really quite monstrous, but it's pretty similar to the last example we did. Okay, this one and this one, just using the product rule. Okay, good luck. I'm going to be checking them in class. Okay, that's all from me. I hope you took notes. You need to. I will be checking in class. You need to have all those notes plus those 3 questions. That's your homework for next lesson. Okay? Bye.